Hi everyone, welcome to the new lecture of Chemical Engineering Thermodynamics. So in the last class, right? So in the last class we were discussing about what entropy, ठीक है? तो entropy के बारे में almost right हमारा definition हो गया है, right? So सब कुछ हो गया है. So in the last class हमने कहाँ पे stop किया था? We stopped at entropy increase principle, मतलब how the universe entropy is increasing, right? So उसका एक proof भी चाहिए था हमें. So we'll start with the basic equation, right? So what is the general equation for entropy change calculation? That is delta S is equal to, entropy is a state function, it is a property, so entropy at the second state minus entropy at the first state will be equal to, you all know how to calculate it, that is integration of 1 to 2 del Q by T, right, plus entropy generation. Clear? I hope you remember. So this is your basic equation for finding the value of what? Entropy change, right? So class में मैंने ये भी बोला था आपको, right? That is the first term denotes our heat transfer, right? Entropy due to heat transfer. अगर heat transfer हो रहा है, मतलब heat added to the system है, right? Then the entropy will increase. If the heat is rejected, entropy will decrease, right? So these things we already told. And the second term is what? It is denoting what? Your irreversibilities, right? Irreversibility, or we can say internal irreversibility present inside the system. ठीक है? So entropy generation will be 0 if it is a reversible process. If it is an irreversible process, it will be greater than 0, right? So these are the things we have told. ठीक है? So last class में, right? So last ending point was this: for an isolated system, what is the meaning of isolated system? There is no heat transfer, there is no mass transfer, right? So if it is an isolated system, the first term, right, that will be 0. So what will be delta S for an isolated system? It will be equal to S generation. You all know S generation will be always greater than or equal to 0. ठीक है, यहाँ तक तो ठीक है, सबको पता है, right? So what about this particular part? So entropy generation can only be what? Greater than 0, right, or equal to 0, right? अगर reversible process है तो वो value 0 हो सकता है, right? Irreversible है तो that value will be positive. So उसके बाद मैंने ये भी लिखा था, that is for example if you remember, that is entropy change can be negative. ठीक है, entropy change can be negative, but the entropy generation can never be negative, right? So these things already we told. Now some students ask me, sir, what is the physical meaning of entropy? Entropy is what normally we will say, right? It is a measure of randomness, right? Measure of randomness we will say, right? Measure of disorder or randomness. Clear? So we normally say what? Entropy of the universe is increasing. Why? Because normally we will say our population is increasing, so the randomness is increasing, right? So since, right, everything is happening, so with each and every process our randomness or entropy is increasing actually. Why? Because we don't have any reversible process, all processes are irreversible. So obviously whatever we have is for every process you will have some entropy generation, right? That we are going to prove it here, right? So up to this is okay. That is for an isolated system, right? Isolated system, the entropy generation is greater than or equal to 0. Now what we are going to do is we are going to split an isolated system, right? Entropy change of a isolated system, right? I'm going to write it as a system, okay? Entropy change as an isolated system, or isolated system, or I can write it as what? A universe also, right? Isolated system or universe. So this I can write it as entropy change for a system plus entropy change for surrounding. So how am I writing universe or isolated system? क्योंकि मैंने बोला है आपको in the first class isolated system का example मैंने बताया था, right? What was the example I told? That is, I am the system because I am teaching in the class. My students are my surrounding, right? A person standing out of my class is not in my surrounding, right? So I hope you remember that example that मैंने बोला था आपको. That is, this is my classroom, okay? This is my classroom. So I am the system here, right? So this is my, this is me, I am teaching inside the class. So whatever students inside, right, whoever students inside my class, those students are what? My surrounding, right? So this is my surrounding, right? And a person sitting outside my class, right, he is not able to listen to me, he is not able to see me, there is no mass transfer, there is no heat transfer, there is no energy transfer, so he is out of my surrounding, right? He is out of my surrounding, so according to him, right, तो इसके हिसाब से, right, according to him, this system plus surrounding combinedly is an isolated system, right? So this system plus this surrounding is combinedly an isolated system according to the person standing outside. ठीक है, so according to him, right, if I relate according to him, मेरा system का boundary कहाँ पे है? This is my system boundary, okay, but where will be my surrounding boundary? That classroom. Clear? My classroom door is my surroundings boundary, right, with respect to him. ठीक है, I hope you understood. So this system plus surrounding, can I consider this total thing as an isolated system? Is it fine? Right, this system plus this surrounding, can I consider it as an isolated system? So for an isolated system, right, for an isolated system, you can say what? For an isolated system, entropy generation, entropy change for an isolated system is equal to what? Entropy generation, and that value will be always what? Greater than or equal to 0. Right, and if there is an irreversible process happening, it will be what? Equal to 0. If it is an irreversible process happening, then it will be positive, that is greater than 0. Clear? I hope you understood. Right, once again I will explain. So now you can see, right, so now you can see, instead of universe, right, instead of universe or isolated system, right, if I consider only this or complete universe, no problem, right, same meaning. So I am saying for an isolated system, entropy change is equal to this, and the total will be always greater than or equal to what? 0. Right, an isolated system, I can take it as what? System plus that surrounding, right, combinedly is an isolated system. ठीक है, now what is the importance of this? I will explain here. ठीक है, अभी आप देख सकते हैं example. My system, right, my system is at a temperature, I am saying 300 Kelvin, okay, my system is at a temperature 300 Kelvin, and my surrounding is at a temperature 100 Kelvin, for example, right? Now, right, now you can see here, now I am transferring, right, now I am transferring, right, now I am transferring 100 joule of heat from system to surrounding. Obviously that will happen because my system is at 300 Kelvin and my surrounding is at 100 Kelvin. Once again, if you have doubt, this is your system and this is your surrounding. ठीक है, once again हमारा system है 300 Kelvin पे, right, surrounding is at 100 Kelvin, so obviously क्या होगा? Higher temperature to low temperature there will be a heat transfer, and the amount of heat transferred is what? 100 joule. Let it be 100 joule. ठीक है, let it be 100 joule. Now tell me, what will be the entropy change for the system? Right, what will be the entropy change for the system? System entropy change will be, what is the amount of heat transferred? 100 joule. What is the temperature of the system? 300. So this will be the entropy change of the system. Entropy change of the system is this much, right? But when the heat is released from the system, right, that amount will be what? Negative. Clear? Because when the hot body is losing heat, the entropy of the body will decrease. Clear? So system will have a decrease in entropy, no doubt. Clear? So that value will be what? Minus 1 by 3 or minus 100 by 300. No problem. Now what about the entropy change of the surrounding? What about the entropy change of the surrounding? It will be 100 joule is added to the surrounding. So it will be what? Positive 100 divided by what is the temperature? Temperature is 100 Kelvin. So this will be the value. So here what is this value? This will be minus 0.33. Clear? That is 1 by 3, right? This will be 1 joule per Kelvin. 1 joule per Kelvin. Now tell me which value is more? Surrounding value is more. Now when I add system and surrounding, what will be my value? If I add delta S of the system plus delta S of surrounding, what will be my value? Minus 0.33 plus 1, this value will be positive, that is 0.67 joule per Kelvin. Now अभी आप यहाँ पे देख लो, right? First of all, there is a system at 300 Kelvin and surrounding at 100. There is a heat transfer process. So our process is a heat transfer process. ठीक है? Now What is the amount of heat transferred? 100 joule from the system to surrounding. Okay, so what we are doing is we are considering, right, if you want, you can consider system plus surrounding is equal to what? Complete universe, no problem, right? In my case, what I am taking is system plus surrounding is an isolated system. I am taking it as an isolated system. You can take it as a universe, no problem, right? System plus surrounding is equal to universe, no problem. Results will be same. Now I am saying for it's an isolated system. Clear? For a better understanding, that's all, right? Now you can see here. What is the entropy change of the system? Minus 0.33, surrounding 1, and if you add, you will get what? This value is positive, which is greater than 0. So according to this, what? The entropy change of the total isolated system is what? Greater than 0. Right? Entropy change is greater than 0. So the meaning is what? Right? For every process, right? Every irreversible process, there will be what? Positive entropy change. Clear? So how can I say this is an irreversible process? Because आप देख सकते हैं, I told you whenever there is a driving force is very very high, right? If we can consider a process as reversible only if the driving force is very very small. If the driving force is higher, what is the driving force here? 300 minus 100, 200 Kelvin. It's a very very high value. So definitely this is an irreversible heat transfer process. Clear? So due to that we can say what? This is going to be what? Positive. Right, your total entropy change is positive. Now, when can I say this particular change is, right, this particular heat transfer is reversible? So for example, second case, I am taking the surrounding temperature as, my surrounding temperature is 299.99 Kelvin. My surrounding temperature is 299.99 Kelvin. Then what will happen here? You can see here, then what will happen? Instead of this, your temperature will become what? 299.99. Then this value will be what? 0.33. And if you add these two, your value of system plus surrounding will be approximately 0. This value will be different, okay? It will be not 0.33, but approximately that. If you add both, you will get 0. Now we can say what? If it is a reversible process, isolated system, your entropy change will be what? 0. Right? And your entropy change will be 0. But we never have what? An irreversible process. All processes are what? Irreversible. So always your value will be what? Generally for every process, your value will be greater than 0. If it is a reversible process, it will be equal to 0. ठीक है, अभी आपको समझ में आ गया ना, मतलब कैसे आपका वैल्यू 0 हो रहा है, राइट? इफ द हीट ट्रांसफर इज रिवर्सिबल, दैट इज आई हैव टेकन वेरी वेरी स्मॉल वैल्यू ऑफ टेम्परेचर डिफरेंस, राइट? टेम्परेचर ड्राइविंग फोर्स. सो आपका वैल्यू क्या होगा? माइनस प्लस दोनों ऐड किया तो 0, right? So if it is a reversible process, your value will become 0. If it is an irreversible process, that will be greater than 0. Clear? So we don't have what? We don't have any reversible process. All processes are irreversible. So what will happen? We can say entropy of the universe is continuously increasing. ठीक है? So system plus surrounding आप अगर universe मान लो, right? So entropy of the universe will be always increasing because universe के अंदर कितना irreversible process हो रहा है, right? You have lot of irreversible processes. Right? So due to everything, what will happen? Your randomness, right, or we can say your disorder, everything is increasing. Clear? So due to the irreversible process happening. Clear? I hope you understood. So once again, this is the meaning. So in your universe, there are a lot of isolated systems, right? Right? Not only my classroom, there are different classrooms. Everything you can assume it as what? An isolated system. By considering system and surrounding, or right, or you, if you want, right, in some textbooks they have taken system plus surrounding is equal to universe. No problem, system plus surrounding. So if I say, if instead of this, if I write universe, the meaning is same, greater than or equal to 0. Clear? So no processor are reversible, every processor irreversible. So your entropy is continuously increasing. Clear? So we have proved also that, right? I hope you understood. So remember this particular example, that is when a process is reversible, the value is coming approximately to 0. Your entropy change value is approximately coming to 0. Clear? I hope you understood. Then we will solve some problem. Clear? Before solving the problem, we need to write some things. 1 minute. I hope up to this is okay. Right. Now what we need to clear here is, if you take the first case, right, that is 100 Kelvin, you can see here, right, 300 to 100 there is a heat transfer, 100 Kelvin, so this is 1, this is equal to what, 0.67. Now, so you can see during every heat transfer process, right, during every heat transfer process, your net entropy is increasing. Clear? During every heat transfer process, your net entropy is increasing. Now you can see here very specifically the decrease in entropy of the hot body, right? Decrease in entropy of the hot body is less compared to the increase in entropy of the cold body. Once again, आप यहाँ पे देख सकते हैं, right? 1 minute, my mic is disturbed. Okay, 300 Kelvin, this thing is our hot body. What is happening to the entropy of the hot body? It is decreasing because heat is released from the hot body. So what we are saying is decrease in entropy of hot body is less compared to right, increase in entropy of the cold body, क्योंकि आपका cold body is receiving heat, so entropy of the cold body is increasing, so is less compared to increase in entropy of cold body, right? That is, you can see this is the decrease in entropy, this is the increase in entropy, so overall the net entropy is increasing, right? So we can say what, entropy of the universe is increasing, right? That is, you can write net entropy is increasing. Clear? So complete up to this, right? So the net entropy of the combined system or combined universe or combined isolated system is increasing. Clear? So complete up to this. Clear? So there is no actual processes truly reversible, everything is irreversible, so automatically your entropy will be continuously increasing. Clear? Now, yesterday somebody asked, right, the same thing, what is the meaning of entropy physically? You can see the meaning is what, if it is a solid body, the entropy of the solid will be what, less, right? That is, it is somewhat in an ordered shape, right? It is having less disorder, but when it becomes liquid, disorder increases. When it becomes gas, it is higher disorder, right? So randomness is increasing. Clear? So this is the way we need to understand the things. Clear? So we'll solve a problem now. You can read the question. Heat source at 800 Kelvin, okay, heat source at 800 Kelvin losses 2000 kilojoule of heat to a sink at 500 Kelvin and sink A at 500 Kelvin and sink B at 750 Kelvin. Determine which process is more irreversible, right? Determine which process is more irreversible. This is the question. So let me see the question first, right? I will read the question once again. You can see here, heat source at 800 Kelvin losses, right? So I am drawing the diagram, right? Heat source at 800 Kelvin. This is a textbook question, right? No, not a gate problem. Losses 2000 kilojoule of heat to a sink A at what? We can say, and again I will draw it once again, right? That is, this is our heat source which is at 800 Kelvin. It is losing heat at a rate of 2000 kilojoule to a sink A which is at a temperature 500 Kelvin and sink B at 750 Kelvin, same amount of 2000 kilojoule. Now, which process is more irreversible, A or B? Right. So first of all, there is no need to solve this particular question, right? Because you know, right? That is, if the driving force is more, definitely that process will be what? More irreversible. Clear? 800 to 500 Kelvin heat transfer will be more irreversible compared to 800 to 750. Right, definitely whenever the temperature difference is small, that process will be what? Less irreversible. Right, less irreversible we can say, right? But here the temperature difference is more, right? So we can say that will be what? More irreversible. So your answer will be A, no problem. Like what is the importance of this question is we need to understand or we need to find it by the use of entropy, right? How can we find it based on entropy? That is the only question, right? So first of all, for first process, what is the change in entropy of the system? Right, what is the total net entropy change? How can you calculate? What is our system? Our heat source is at 800. What is the entropy change of the source plus what is the entropy change of the sink? Right, calculate the net entropy change for source plus sink. That is our total system. Right, so find it. Then we can decide. For question A, what will be the entropy change for the source? It will be, what is the amount of heat released? It is minus 2000 divided by 800. What about sink? It will be 2000 kilojoules taken, right? So it is heat is added to the sink. So it will be what? Divided by 500. This will be the what? The value for the first case. What about the second case B? Delta S will be equal to minus 2000 divided by 800 plus 2000 divided by 750. Clear? So find the answer. What are the answers? For the first case, the value will be 1.5. Second case, the value will be, any answers? 0.166. So both cases you can see that net entropy is positive, right? Both cases you can see both processes are irreversible, right? So both cases the entropy is positive. So whichever system has more entropy, that will be what? More irreversible, right? Whichever system has more entropy change, so this will be more irreversible, right? This will be more irreversible. Clear? So this is the way we will be finding. Done. So we have a lot of questions based on this, right? A lot of gate questions are there based on this. That also we will do. Clear? Next type is, already we have discussed the topic, but still, right? So we have another topic called isentropic system, right? Isentropic process, not an isentropic system. What is an isentropic process, right? So obviously you know, right? If it is an isothermal process, temperature constant, isochoric process, volume constant, same way. What is the meaning of isentropic process? Right? So obviously what should be the meaning of isentropic process? Entropy should be constant, right? That is, during a process your entropy should be constant, right? Your entropy during a process should be constant. Clear? So what is the equation for entropy change? Actually it is 1 to 2 del Q by T plus entropy generation, right? So if there is no heat transfer, this term will be 0, right? So the process, if the process is adiabatic, we can say what? It is heat transfer is 0, right? Then there will be no this term. If the process is reversible, we will say S generation is also cancelled, so this value will be equal to 0. Now, so we can say reversible adiabatic processes are isentropic. So all reversible adiabatic processes will be isentropic. Clear? So completed. Right? You can write it, all reversible adiabatic processes are isentropic. Because if a process adiabatic, the first term is 0. If the process is reversible, the second term is 0. So delta S is 0. So meaning is what? S1 is equal to S2, entropy is constant. Right? लेकिन आप देख सकते हैं delta S is equal to 1 to 2 del Q by T plus, right? 1 to 2 del Q by T plus entropy generation. Clear? 1 minute. So my question is, I can say all the reversible adiabatic processes are isentropic. Can I say the opposite? That's my question, right? My question is, can I say all the isentropic processes are reversible adiabatic? Can I say the opposite? That is my question, right? I can say all the reversible adiabatic is isentropic, but can I say the opposite? Right? Always it may not be true, right? For a simple example, right? We can say you have a heat generation of some 10 joule per Kelvin. For example, I am saying 10 joule per Kelvin, and due to a heat loss, your this term can be what? Minus 10. So minus 10 plus 10, delta S is equal to 0, S1 is equal to S2. This also a possibility, no? Right? If there is a heat loss in a process during an irreversible process, this also can happen, right? Right, this also can happen. So practically, right, we will say, right, generally we will not say all isentropic processes are reversible adiabatic. We will not say that, right? But all the reversible adiabatic are isentropic. But the simple thing you need to remember is, right, so this is for your information only, but in GATE, most of the cases whenever they give you isentropic, right, in GATE I am saying for chemical engineering, most of the cases if they give isentropic, we can take reversible adiabatic and solve, right? So that is the important thing in our GATE, right? Now, we are interested in a process diagram. The process diagram which will have T in y-axis, and that is temperature in y-axis, entropy in x-axis. TS diagram. Clear? So what will be the TS diagram? How will be the TS diagram of an isentropic process? Entropy should be constant, right? So it will be like this, right? That is isentropic process meaning is what, right? Reversible adiabatic, that is entropy should be constant. So we can say S1 and S2, right? That is 1 to 2 process if it is 1 to 2. So this is an example of what? Isentropic process. How can we represent isentropic process in a TS diagram? Clear? So complete this. Now, the speciality of a TS diagram, right? So what is the speciality of a TS diagram? If you remember our equation, what is ds? We know our entropy change ds is del Q reversible by T, or we can say what? Total for a reversible process, del Q by T is ds. So if I multiply with T this side, TdS will be equal to what? Heat transferred during a reversible process. Right now, if it is a TS diagram, right? If it is a TS diagram, right? If it is a TS diagram, what will be the area under the TS diagram? The area under the TS diagram will give me the heat transfer during reversible process. What is the meaning? If you remember, del W is equal to minus PdV. It was our closed system work, and we told in a PV diagram, right? In a PV diagram, the area under the curve will give you the work done. Same way, in a TS diagram, right? In a TS diagram, the area under the curve will give you what? The heat transfer, right? So the area under, you can write it. The area under TS diagram will give you, right, will give heat transferred during reversible process, right? Heat transfer during reversible process. So isentropic process के लिए, what is the area under TS diagram for isentropic process? This is for isentropic process, right? ये तो आपका isentropic process था. So what is the area under isentropic process? What is the area under this graph? Here the area is what? 0. What is the meaning? Area under TS diagram is 0 means reversible heat transfer is 0. What is the meaning? If the heat transfer is 0, it is reversible adiabatic. Heat transfer is 0. Clear? I hope you understood. Right, clear? So this is the meaning. So due to this, generally we will take what? Isentropic process, reversible adiabatic, vice versa also for solving our problems in GATE. Right, but the other option is also possible that you need to keep in your mind, that's all. Right, for solving problems and in our exams we can use it. Isentropic, reversible adiabatic. Clear? ठीक है? Now, up to this is fine. Now, how can you draw TS diagram for a Carnot cycle? Carnot heat engine, Carnot cycle. How can you draw the TS diagram? Very simple. Temperature, entropy. What are the four processes in a Carnot cycle? All processes are reversible. All processes are reversible. One process is reversible isothermal expansion, reversible adiabatic expansion, reversible isothermal compression, reversible adiabatic compression. So आपके पास दो isothermal processes है, that is temperature constant, right? मतलब you have two processes whose temperature is constant. Reversible adiabatic meaning is what? Entropy is constant. Isentropic process मतलब आपका Carnot cycle जो है, you have two isentropic process and two isothermal process, right? So how will you represent two isentropic processes in a TS diagram? Two values in two different temperatures, right? That will be the two isentropic processes, right? That is your adiabatic process. Two isothermal will be coming like this, right? So you will have a diagram like this, right? You will have a diagram like this. We'll say rectangular diagram that is like this. Clear? So I can say this was TH. This line denotes TL. This denotes S1. This denotes S2. Clear? So if I say 1, 2, 3, 4. 1 to 2 denotes my isothermal expansion, right? 2 to 3 denotes my adiabatic expansion. 3 to 4 denotes my isothermal compression. 4 to 1 denotes my adiabatic compression. Clear? So tell me, what will be the area under this diagram? Right? What will be the area under this diagram? It will be your work output. How it will be the work output? Very simple here. That is, what is the area under 1, 2, 3? That is during compression. What is the area under the compression? That is, the area under the compression will be this entire thing. Clear? So that will be what? That will be your heat transport QH. Right? For example, if you see, let me use another ink. Area under 1, 2, 3 will be the entire area, right? This entire area will be covered. Minus area under 3, 4, 1 will give you the area inside this. So that will be what? QH minus QL. Clear? So that area will be QH minus QL, because area under 1, 2, 3 will be QH. Area under 3, 4, 1 will be QL. So QH minus QL will be the area inside. What is that QH minus QL? So QH minus QL is your work. Clear? Same thing, right? It's very simple to understand. So just remember this, right? So these are the things we need for solving our problems. That is for chemical engineering things. We require this much only, right? So we'll have entropy change for ideal gases also, right? So that will finish our entire topic of entropy. Clear? So we can solve all the 8 questions as well from entropy with only this much information. Clear? Right, now once we are done with this TS diagram, right? Once we are done with this TS diagram, we are interested to combine our first law and second law. That is, your first law is about du is equal to, right, del q plus del w. I hope you remember, right? And second law is about entropy. Clear? So if you remember this, what is the equation for first law of thermodynamics? For a closed system, du is equal to del q plus del W, right? We used to write it for a reversible process, so this Q I can write it as reversible. This is also reversible work done, no problem. Now, just now, right? Just now I have written this, right? Just now I have written this. That is, our second law is ds is equal to del Q divided by T for a reversible process. So instead of del Q reversible, can I write it as TdS plus reversible work done? What is the equation for reversible work done? Minus PdV according to us. So this is relation 1 for us. TdS minus PdV. Clear? This is relation 1 for us. TdS minus PdV, right? So now we have combined what? Our first law and second law both, right? So this is one of your property relation that we will discuss next. So du is equal to TdS minus PdV. Clear? I hope you have this. Now you have one more term, right? Enthalpy is equal to U plus PV, right? What is dH then? dH is equal to du plus PdV plus VdP. What is du? TdS minus PdV. Substitute. So dH will be what? It will be du is TdS minus PdV. So minus PdV plus PdV cancelled out. आपके value क्या आएगा? It will be TdS plus VdP. So this is another case, right? This is another equation. So equation 1 or 2, right? Both are in your property relation. And ये equation का importance क्या है? You can see we can use these two equations for any process. Reversible or reversible doesn't matter. क्योंकि आपके जो जितने भी values आप देख सकते हैं, right? जितने भी values आप देख सकते हैं, because H is a property, state function, right? Doesn't depend upon the path. Entropy, state function. Pressure, state function. Internal energy, entropy, volume, everything is state function. So there is no heat work term is involved, right? So आप ये दोनों equation कहीं पे भी use कर सकते हो. You can use it anywhere. Clear? So based on this, we are going to calculate what, right? What is the entropy change for ideal gases? Clear? So that we are going to do. So remember these two equations, right? Remember these two equations carefully. In our Maxwell relation or in our thermodynamics 2, we are going to use these two equations very well, right? So remember these derivation if you want to remember, because these two equations are very much important for us. ठीक है? यहाँ तक तो ठीक है ना? So we'll move to the next. Clear? यहाँ तक तो ठीक है ना? So next topic is entropy change for ideal gas. Entropy change for ideal gas. That is simple, right? Don't complicate the equations, okay? मतलब बहुत सारे equations होंगे, right? With number of moles, mass, etc. But basic equation we will discuss, right? Number of moles है, mass है, etc. That you need to find it from the question. Unit के हिसाब से you need to multiply and solve, right? Not interested in that, right? We will understand how we are deriving it, right? So it is according to your logic. You should add the number of moles, mass according to the question. ठीक है? So first of all, ये equation use करके we will try to make an equation. ठीक है? So first of all, du, we are starting with du equal to TdS minus PdV. Ideal gas के लिए what is du? Du is CV dt. Ideal gas. Now equal to TdS. What is the ideal gas equation? PV is equal to sorry, excuse me. Sorry, that was unexpected. Right? Those who were having headset, right? So sorry for them, right? That is, they might have heard a very big sound. Okay. So sorry for that. So PV, right? So PV is equal to, we know it is nRT. I am taking number of moles is equal to 1. So it is PV is equal to RT. R is what your universal gas constant only, right? So it is PV is equal to nRT. So instead of n, I am taking 1. That's all. You can use it later, right? You can use the number of moles later, no problem. So what is your value of P? P, can I write it as what? RT by V. So substitute here. So TdS minus RT by V into dV. So use it. So try to write it with me, okay? Otherwise आप लोगों को समझ में नहीं आएगा, right? Okay. Now bring this T this side, right? Bring this T this side or divide by T. So आपका value क्या होगा, right? It will be CV into dt by T equal to ds minus R by V, or I can say R into dV by V. So bring this term this side. What will be the value of ds? ds is equal to CV into dt by T plus R into dV by V. So integrate this equation. What will be delta S? CV into ln T2 by T1 plus R into ln V2 by V1. This is one equation you can remember. Right. Now those who are asking how can you take CV outside of the integration, that I have taken by assuming these values are constant. Right. In the question, if they give us a function, keep it inside this and solve it. Right. And see the number of moles also. Right. What is the unit of delta S? If it is given in kilojoule per kg Kelvin or kilojoule per Kelvin, kilojoule per kilomole Kelvin, depends on you. Right. So this is the way we are going to develop the equation. That's all. Right. How we are using this equation, that we will see in the problem. Okay. So you need to, if you want to remember it, remember. Otherwise, no need here. Simple derivation. Okay. So if you want to remember it, you can remember it. Otherwise, it's very simple derivation. Okay. Now, same way, you have another equation based on this relation. Now check. What is dH for an ideal gas? dH for an ideal gas is Cp dt, right? Cp dt equal to same step TdS plus VdP. Now tell me, what is TdS? What is V for ideal gas? It will be RT divided by P. V is RT divided by P. Now divide every term by temperature. So Cp into dt by T will be equal to ds plus R into dP by P. So integrate, or ds is equal to what? Cp into dt by T minus R into dP by P. So find the value of delta S after integration. Cp into ln of T2 by T1 minus R into ln of P2 by P1. So this is the second equation you need to remember. By using P1 V1 by T1 is equal to P2 V2 by T2, you can get an equation in terms of volume. Right? You may have a third equation as well. Do that also. Right? So these are the things you need to remember. Clear? I hope up to this is fine. So sorry for the disturbance. So we'll start with a question in GATE 2013 IIT Bombay. You can read the question. In a process occurring in a closed system F, the heat transferred from F to the surrounding E is 600 joule. If the temperature of E is 300 and that of F is in the range of 380 to 400, the entropy changes of the surrounding and system are given by. Option A is given, B is given, C is given, and there is option D as well. Clear? So those who want to read the question again, pause the video and just read the question. In process occurring in a closed system F, heat transferred from F to the surrounding E is 600 joule. Temperature of E is 300, that of F is in the range 380 to 400. Entropy changes of the surrounding is given. So solve. Clear? I hope you have read the question. So what will be the answer? So let me check the question. So 1 minute. Let me read the question. That is process occurring in a closed system. Okay, again it's a closed system. They are saying in a closed system system is F, right? So this is your F, system is F. Heat transferred from F to the surrounding E, so surrounding is E, heat transferred is 600 joule, clear? Now temperature of E is 300 Kelvin and system temperature is 380 to 400, you can take it as 390 also, right? No problem, right? And what is the entropy change of the surrounding and system? So first of all, what is the entropy change of surrounding E? Very simple, Q by T. What is the heat transferred? Positive 600 joule divided by 300 Kelvin. So it will be 2 joule per Kelvin. So you can check the option A, B, C, D. Which option has entropy change of surrounding equal to 2? Option A is okay because they have given entropy change of surrounding is 2. Option C is also entropy change is 2. Option D is also entropy changes too. So with only this you cannot find it. Okay? So find for what? Entropy change of system. What will be this? System is losing heat, so minus 600 joule. What is the temperature? Temperature can be, you can take it as 400 or 380, 390, no problem. I am taking it as 400, okay? You can take it in between 380 and 400 also, no problem. Right? For getting the answer fast, I don't want to use the calculator, so it will be minus 1.5 joule per Kelvin. So you got the value, entropy change for system also. Now check the option. Right. So you know option A cannot be true because A option is, they are saying entropy of the system is minus 2, so that cannot be correct. Now the problem is, they have given entropy of F is less than minus 2, entropy of F greater than minus 2. So हमेशा हमें प्रॉब्लम क्या होता है? Right, understanding this. ठीक है, minus 1.5 तो मिला है, लेकिन उस टाइम पे क्या प्रॉब्लम हो सकता है? You may think like minus 1.5 greater than minus 2 है या less than minus 2 है? ठीक है? So if you have any confusion, draw it. Right, draw your coordinate axis and mark and understand. Okay, minus 1.5. Right, minus 1.5 comes here. Minus 2 comes here, so what will happen? Minus 1.5 is greater than minus 2. Clear? So find the answer, and that is your first question. Right? ऐसे कुछ simple doubt आया तो, right? Don't waste your time. Just draw and find it and find the answer. Right? ठीक है? That's all. Next question. Right? So can we move to the next question? The next question is in 2007. Which one of the following represents Carnot cycle ideal engine? Right, so you know it is PV diagram, TV diagram, and option C and D are this. So TS diagram is there, and you can see, right, the diagram of TS. So obviously, which will be the answer? Your answer will be option C. Just now we have discussed in the class, right? That is TS diagram of a Carnot engine. Clear? I hope option C correct answer. Now the next question. 2 kg of steam in a piston cylinder device at 400 kilopascal and 175 degrees Celsius undergoes a mechanically reversible isothermal compression. Mechanically reversible isothermal compression in a piston cylinder device to a final pressure such that steam becomes just saturated. Okay, steam becomes just saturated. Now, what is the work required for the process? They have given the data. Right, so you can see temperature is given, pressure is given, volume is given, internal energy is given, entropy is given. Clear? Temperature 175 for saturated vapor also they have given. The specific volume, internal energy, entropy is given. So see the given value and then try to solve. So for those who couldn't read the question, right, so you can pause the video and read it. But anyway, I will be writing the given values on the board. Okay, so it's a question based on closed system, that's for sure, because it is a piston cylinder device, so it's a closed system, there is no doubt in that. Now you can see it's a compression process, right? Compression process, there are the things given. So let me write first of all the given value. Okay, so 2 kg of steam, so mass of the steam is 2 kg, no doubt in that. Mass is 2 kg, no doubt. In a piston cylinder device at 400 kilopascal, so pressure is 400 kilopascal, and temperature is 175 degrees Celsius, undergoes a mechanically reversible isothermal compression. So meaning of isothermal compression is this 175 degrees Celsius is going to be constant, no problem, right? To a final pressure, so P1 is final initial pressure, to a final pressure such that steam becomes just saturated. So we don't know what is P2, but it is a saturated steam. You need to find what is the work done, right? What is the work done, right? So this is what we need to find it. Clear? Up to this is fine. Now, what is the work required for the process? So temperature 175 and pressure 400 kilopascal. The data is given. V is 0.503 meter cube per kg. This is the specific volume. Entropy and internal energy is given 2606 kilojoule per kg. So it should be what? Specific value, that is your intensive property, right, or extensive property. So extensive means there will be no per kg will be there, so this is an intensive property, right? Now entropy for this case is 6.6, sorry, the value is 7.705 7.055 kilojoule per kg Kelvin. Now for second case, temperature is 175 degrees Celsius, and when the steam is saturated, right, when the steam is saturated vapor, right, steam is saturated vapor. Now what will be the value? Volume is, specific volume is 2.216 meter cube per kg. They have given internal energy is 2579 kilojoule per kg, and entropy is 6.622 kilojoule per kg Kelvin. So these are the values given. Find what is the work required for the process. Determine it. Clear? First of all, they are asking you what is the work transferred, right? What is the work transferred? They are asking. What is the question? So once again, 2 kg of steam in a piston cylinder device undergoes a mechanically reversible isothermal compression to a final pressure such that, right, determine the work required for the process. So it's a closed system. First write whatever you know, whatever equations you know for the closed system, right? So what is that? First equation is du is equal to del q plus del w. This is the first equation I know because it is a closed system. Okay? So the internal energy change in a closed system is equal to del q plus del w. Since they have given entropy here, right? Since they have given entropy here and it is an isothermal process, instead of del q, I am writing what? TdS. Del w is what? Minus pdv. So you have this equation, right? du is equal to TdS minus pdv. Simple. Now problem is, can I write, it is an isothermal process, right? Can I write du is cv dt and it is equal to 0? Can I write it? I cannot write it because it is not an ideal gas, right? It is not an ideal gas. They haven't given it as ideal gas. And आप ये भी देख सकते हैं, the u value u1 and where is u2? This is u2. Both are different. So u1 minus u2 is not equal to 0. So you cannot write du equal to 0. Right? By taking cv dt isothermal process, you cannot cancel it because it is not an ideal gas process. ठीक है? यहाँ तक तो ठीक है. So integrate कर लो equation को. Right? So when you integrate it, 1 minute, let me see. Right? So it is integrated. What will be this? It will be u2 minus u1 will be equal to temperature into S2 minus S1 minus pressure P, right, minus P into V2 minus V1. Clear? Everything is same, right? Right, everything is same. That is ds will become what? S2 minus S1, P into V2 minus V1. Simple. So complete it and solve and find the answer. All the values are given, right? But my question is, can we write it as P into V2 minus V1, because it is not a constant pressure process? So how can you take the P outside? You cannot do that, right? Right? Simple, right? It's not a constant pressure process, so you cannot take the pressure outside and you can write what? V2 minus V1. Not correct. So keep this as what? Del W itself. Keep this as del W, and if you integrate, this will become what? Work done for reversible. You need to calculate the reversible work done, right? Simple. So keep the work done reversible here, right? And solve it. You will get the answer. What is the value of reversible work done? You have two values. Find it. U2, U1 is there, and substitute and find the answer. Clear? So let me substitute now. What is U2 minus U1? U2 is 2579. 2579 is U2. U1 is 2606. 2606. But this is in what? This value is in kilojoule per kg. Right? This is in kilojoule per kg. You need the answer in what? Kilojoule. So multiply by the mass. So I have multiplied by mass. So mass is 2 kg. Kg cancel, your answer will come in kilojoule. So this is only U2 minus U1. I need to take this that side. So it will be what? Minus of temperature into what is entropy? Second entropy is 6.622 minus first entropy is 7.055. Again, temperature, what is the temperature? 175 plus 273, right? You will get the 448. But again, kilojoule per kg Kelvin multiplied by Kelvin, you have to multiply by what? Mass, 2 kg. So find the answer. What will be the reversible work done? 2579 minus 2606. So do the calculation and tell me the answer. I hope all of you are getting the answer. Your answer will be almost 334 kilojoules. Right? So do the calculation. So your reversible work done will be 334 kilojoules. Clear? Which option? Option C. Right? You will be getting C. If there is any value problems, you can check it, but the method is same, right? First write the first law equation for a closed system, du is equal to del q plus del w. We need to find what? Del w. So change only two things. There is no need to write minus pdv here because you need to find w, right? Right. Moreover, you cannot find del w by taking pressure outside. Simple. I hope up to this is fine. Clear? And more question we can solve tomorrow, right? By tomorrow your mostly your thermo 1 will be over by tomorrow. So from Monday we can start thermo 2. Clear? So that is what I am planning. So by tomorrow almost all questions from thermo 1 will be done with one small open system compression, right? That some parts are remaining, multi-stage compression is remaining. So with that we will finish our entire thermo 1. That is most important topics in thermo 1 will be over by tomorrow. Then from Monday we can start thermo 2. Clear? That's all. Thank you very much.